I'm Tim Ventura from American Antigravity, and today we're joined by Dr. Eugene Podkletnov to discuss his experimental research in gravity modification in superconductors. For nearly 2 decades, Dr. Podkletnov has been researching the link between gravitation and high-temperature superconductors, and just recently published the peer-reviewed results of new experiments he's conducted to measure the speed of a force beam projected by a stationary superconducting apparatus he's developed. So let's start out by describing the force beam generator. Dr. Podkletnov, thank you for joining us. From what I understand, this device pulses a high voltage discharge from Marx-generator through a stationary superconducting emitter in a magnetic field. Can you describe that for us a little
bit? Yes, I will try, though the installation is pretty complicated, but the principle is pretty simple. So we have a typical high voltage discharge. The voltage goes up to 2 million or, at the exception, up to 5 million volts. We have a superconducting emitter, which is a double-layer superconductor. One layer is made of superconducting material, another layer is made of normal conductor. That is the secret of the production, but the main requirement to the emitter. So during the discharge from the Van der Graaf generator, we have an interesting phenomenon that is not typical for usual discharge. So this discharge is accompanied by a gravity effect, and the emitter emits, we can call it virtual gravitons or gravitational waves. So they propagate at very high speed to very big distances, not losing their energy, and they're able to interact with normal matter. So during last 6 or 7 years, we were studying this effect and measuring all the phenomena that accompany this effect.
I should point out that this is very different than the rotating superconductor experiments you conducted in the 1990s, and that in the case of the force beam generator, it creates a substantial amount of force. I believe you've indicated it was enough to sometimes knock things over in the lab. Is that correct?
Yes, that's absolutely correct. But if we compare the rotating disk and the impulse gravity generator, the principle is the same, because we create a high density electric field in both materials. So in the rotating disk, the emission of gravity waves is not so efficient, and it is pretty slow from all over the surface. And during the processes in the impulse gravity generator, we have a high voltage discharge, and the intensity of the gravity radiation is much bigger, though the time is very short. It's about usually 60 or 70 nanoseconds. But the gravity beam is able to knock down different objects that stand in the field of the projection area, or under certain conditions it is possible to make holes in brick walls, and it's possible to bend metals. So it's a very powerful tool.
Now, have you been able to measure the amount of force generated, and have you found any correlations between the amount of energy used in the Marx discharge and the amount of force generated in the beam itself?
Yes, we tried to make it, and there is an article together with Professor Giovanni Modanese. So this is available on the net in Los Alamos database. So sometimes the energy is comparable with what we have in Marx-generator, but sometimes it is bigger. And we don't speak about over-unity device, but simply we create the conditions when energy that is inside solid bodies or inside physical vacuum, it can be extracted and sent to a certain direction.
Now, you'd also described a strange effect that was happening behind the beam generator. Have you been able to explore this at all?
We noticed that during the discharge there is a certain emission of radiation on the backside of the device, and this radiation has some harmonics, and the frequency is not quite clear. It's difficult to measure it. So this effect allows this radiation penetrates different materials, and it can weld metal objects, for example, with plastic objects. So this is not a pleasant thing. But we notice that this field exists only at the distance of several meters. Then the intensity goes down, so this is not dangerous at all.
Oh, okay. Now, are there any thresholds involved with this experiment? Perhaps maybe it works only over a certain voltage or magnetic field intensity?
Yeah, that's absolutely right. We have usually all the effects at the voltage of 500,000 volts. If it is lower, then the effect is not so obvious, and it's difficult to notice it. But the bigger the voltage, of course, the bigger the effect.
Interesting. You know, one thing I'd also wondered about was, I believe it was Ron Kosher had speculated that in a discharge event like this, you have a lot of harmonics in the spark itself, and he had wondered if maybe that played a role in creating the effect.
Maybe. I agree with this approach. There are a lot of things that we should study more and in detail, of course.
Yeah. Now, I'd like to ask, have you discovered any refinements to this process that make it more efficient or powerful?
Yes, we noticed that if we want to obtain really a powerful pulse, then the time of the discharge should be as small as possible, and also there is a parameter when the voltage grows up, so this erection time of the voltage should be as small as possible. Under these circumstances, the pulse becomes extremely powerful, so that you can make holes in metals, and at big distances, the energy is not lost at all.
Oh, okay. So reducing that ramp-up time for the voltage is important then. Now, how many experiments have you conducted with this so far? Probably hundreds, right? Because you've been working on this for...
Probably hundreds, yes.
Yeah, and this goes back, I think, about 10 years, right?
Yes, I think the first article appears in 2000 or 2002, something like this, and we were working very hard with this topic.
Well, just recently you published a paper on these experiments titled The Study of Light Interaction with Gravity Impulses and Measurements on the Speed of Gravity Impulses, which you co-authored with Dr. Giovanni Modenese, and that describes the propagation speed of the force beam. Now, in that paper, you guys had actually done a lot of measurements on the speed, and it looks like you use two different types of measurement devices, right?
Right. So our main goal was, first of all, to determine the speed of the gravity impulses, and to study the interaction of the gravity impulses with laser beam. And in fact, there are two parallel experiments. And the results were pretty amazing because, first of all, we were maybe the first team who tried to determine the speed of the propagation of the gravity impulses at the distance of more than 1 kilometer. And we used very precise equipment. We used rubidium atomic clocks, 2 of them, synchronized clocks. And we were able to determine with high precision the propagation speed of the gravity impulses. And we repeated these experiments for nearly half a year. And we used different voltages, we used different conditions, different emitters, but practically always with a very good precision and low deviation. We got the figure of 64C, which means that the gravity impulse is propagating at the speed 64 times faster than the speed of light.
Wow, wow. Now, because of this massively high propagation speed, does that increase the margin for error in your experimental measurements?
No, the error of the measurements is very low. First of all, because rubidium atomic clock is a very precise device. And also, we repeated the experiments many times. We also used very sensitive piezoelectric sensors, and the measurements are described exactly with good precision in our article. So we think that, and we're practically sure that, of course, there is a small place for an error, but it is really small.
Well, in reading through the experiment, you guys had done amazingly detailed write-ups on this, and it was very carefully conducted. So that the piezo crystals respond, if I understand this correctly, to changes in pressure, and so they're picking up a mechanical change. And the other experiment you had done for measurements almost looked like a wave interferometer. Would that be accurate?
Yes, we can say so. And so the second experiment was when we had a laser beam, which was situated in the projection area of the gravity beam, so that the laser beam was at a small angle along the propagation line of the gravity beam, and we had the distance of about 60 meters where the laser beam crossed the projection area of the gravity impulse. And we noticed that the intensity of the laser beam was changing when the pulse was activated. And the intensity diminished up to 7 or 9% under certain conditions that depended on the voltage of the discharge. But it's pretty obvious that the gravity pulse can blow away some photons, some particles that propagate inside this area. And though the action was very small, but the devices are quite precise, so again, we cannot say that there was something wrong with the measurements. And again, it was repeated several times. So it's a very interesting phenomenon.
Well, and at 64 times the speed of light, that's very different than I think what relativity has described, although at the same time I've seen a lot of models that place the speed of gravity as being much higher. Do you know of any support in physics for that particular speed, or is there anything that indicates that that might be something that we could expect to see in these experiments?
Well, first of all, if we speak about the theory of relativity, Dr. Einstein never limited the speed of gravity, so he didn't even discuss these problems. So from his point of view, there is no contradiction. Also, the gravity wave practically has no mass, and we can call it a gravity wave, which means gravity wave is in fact a distortion of media. What media do we distort? It's what we call ether, or subatomic particles, several orders of magnitude smaller than the electron. They have no friction when they interact with each other, with other particles. They have no mass. So there is not a surprise when the gravity wave goes with a speed much faster than the speed of light. Also, during solar eclipses, it was noticed in earlier times and during recent years that during the eclipse, when we watch the sun or some other planets, the information comes to us with the delay. And so when we see the eclipse, the planets are already in the other position because they move pretty fast in space. And I think that Russian astronomer Kozyrev was the first who measured the radiation which comes from the sun and other stars. So that radiation is pretty powerful, and that means that this radiation comes much faster than the speed of light. And our experiments with laser beam shows that really the gravity rays or gravity beam, it can take the particles of light and move them with very high speed. So that's the way how we determined them. And that's the way how Kozyrev determined them in the first place.
Yeah, Dr. Tom Van Flanderen had told me in a previous interview years ago that when orbital calculations are being done, orbital calculations always assume an infinite speed of gravity as opposed to, having it limited by the speed of light. And he'd actually said that, if you substituted the value c, those calculations would not be accurate, and the planets literally would not orbit the sun the way that we know that they do. So I think there's a lot of supporting evidence for a much higher speed of gravity. Now, I guess I probably should back up a little bit and ask, is this force gravity, or is that something that I think yourself and others have called it just because we're not really sure what else to call it?
I usually approach all this research as an experimental physicist. And, for example, Giovanni Modanese, he approaches this as a theoretical physicist. So he's very accurate in giving corresponding terms to all the events. So he calls it a gravity-like impulse. And I call it simply a gravity impulse because during last 2 years we made a considerable advance in this research, and using all the information that we had before, we have now the technology which allows us to make objects heavier or lighter if they are in the vicinity of a new device, which we call an artificial gravity generator. So I'm pretty sure that if we make the objects heavier or lighter, this is gravity.
Now, with that description, you're talking about the rotating superconductor research as well, right?
Yes, that's right.
Okay, so you've also continued your research in that area?
Yes, of course. And if we speak about superconductors, Now we understand that superconductors were extremely useful as model materials because they allow us to create any configuration of the magnetic field that we want. But we can actually work without superconductors using normal conductors and some other composite materials, and they give practically the same effect or even better effect than superconductors. So we now turn back to rotating disks with composite structure, and these disks, under certain conditions, can create a gravity field. So we are working with rotating disks and also with rotating magnetic fields, which are practically the same thing as rotating body, but in a bit different way. So the mechanism is a bit different.
So would it be potentially possible then to eliminate the superconductor entirely and go completely to a rotating magnetic field?
Yes, that's right. So our last research shows that working with composite material that do not include superconductors at all, we are able to create gravity fields in space, in the air, in different objects, and all the objects in the vicinity of our artificial gravity generator, we can control their weight.
Now, have you published any papers describing that? Because that's not something I'm familiar with, but I would love to read more about it.
No, these things are entirely new. So we haven't published any materials yet because this is part of our know-how, and we also prefer not even to make any patents at present because we would like to go directly from the stage of research to the stage of engineering and application.
Yeah, I understand that you've been looking seriously at commercial applications for all of these technologies. Can you tell me about a few of the applications that particularly catch your interest?
Well, the main application, of course, will be the transportation system. It will be a new transportation system on the planet Earth and in space, because our technology allows to move very heavy objects with big speed, or on the contrary, with very low speed. We do not pollute the environment. We don't have any radioactive materials. The system does not produce noise, does not produce exhaust gases, and takes very small amounts of energy to activate it. So it's practically the dream of every engineer. At the same time, parallel to transportation, we can speak about energy production, new energy production plants, which are based on artificial gravity generators, because any turbine can be, half of the turbine can be made heavier or lighter, and it will begin to rotate just by itself. So it's a new approach which will later eliminate all oil or gas burning power plants. Also, we want definitely to eliminate radioactive materials. And our systems are reliable, very safe, and much more efficient than the systems that people use at present. And definitely, speaking about the future of these artificial gravity generators, we can speak about traveling to different planets, because now it will be much easier than with primitive rockets. And we can speak about mining in space, because with our systems we can bring pretty big asteroids to the Earth very slowly, not burning in atmosphere. And if needed, we can move very heavy objects to the Earth orbit. So if we want to make a series of space stations, that is not a problem. But definitely a lot of research and engineering work should be done, and we think that we are approaching this stage.
Well, I should ask how people can get in touch with you if they'd like to learn more about your work. Do you have a website set up for what you're doing or some of the commercial applications of it?
No, I don't have a website yet, so people who are really interested in this research and people who are interested in investments, they can contact me directly. Of course, I do not work alone. I have a team of scientists from different countries, from Italy, United States, Britain, Russia, and we are good scientists with a lot of professors with PhD degrees, so we are not inventing something. We are very serious. We are very responsible people. I do not think that it is good to make a website because, and also we would not like to demonstrate anything to people because I'm not David Copperfield. I do not work with tricks. It's pure science and a very serious science. So everything can be discussed. I'm open to communications.
Absolutely. Well, and I will definitely forward people your way as well. Well, we're out of time today, but I want to thank you again for joining us, and I hope to speak with you again soon as your research continues to move forward.
Thank you very much. I hope this will be the beginning of the new era in the gravity research.
Thank you again.